Okay, guys, 6.4. We have talked about all kind of factoring in chapter 5. We're going to take this to the next level, okay? So in this subchapter, we talked about special factoring of the sum of two cubes and the difference of two cubes, okay? This is your sum, this is your difference formula. How do we apply that? Let's look at x squared, x to the third plus 27. If you look at this, you'll notice, I'm going to try to do this to where you can actually see me, that my a is x, right? And my b is, what number to the third power is 27? 3, right? So I know that this is basically x to the third plus 3 to the third. I can now go ahead and apply my formula. I can go, this is x plus 3, because it's a plus b, times x squared, which is a squared, minus 3x, minus 3a times b, plus b squared, which is 9. Okay, I just applied that formula step by step, and I write it the way I needed to write. I'm there. What if it's not that self-explanatory? What if it doesn't look like a cube? Because if you look at 16, 16 is not a cube of anything. 8 is, but 16 is not. 250 is not the cube of anything. Should you need to, you just use your calculator, go square cube root of 250, and you get a decimal. But I'm looking at this, I'm looking 16 and 250. They're both even. I can factor a 2 out. Okay? That's the first thing I'm going to factor out. 16 divided by 2 is 8. 250 divided by 2 is 125. And I have a minus. What else can I factor out? I'm done with the numbers. They don't have anything else in common. I have a u to the fifth and a u to the second. We said in class, I basically can take a u to the second out, right? Because it's in both places. If I had 5 u's and I took 2 out, I'm left with 3 u's. And here I had 2 u's, I took 2 out, I'm left with nothing. I actually don't even need that much space, right? Let's see now if we can come up with cubes or not. Can we define A and B? Well, 8 is the cube of 2, and u to the third is the cube of u to the third power. So this A can be 2u. B, 125 is the cube of 5, right? I now have my A, I have my B, and I know this is a difference. All I have to do is plug them in. This becomes 2u, that's my A, minus 5, parenthesis, 2u squared, which is 4u squared, plus 2u, let's not skip steps. I don't want to confuse you. I'm going to actually do it the right way. 2u, which is A, all squared, plus 2u times 5, plus 5 squared or b squared, correct? We just plugged it in everything we know. Let's finish it out. 2u minus 5 times 2u all squared, this gets distributed, 4u squared, plus 10u, 2 times 5 is 10, plus 25. And that's what we get there, okay? And then we're done. This is how we factor this completely. Now, we also talked last year too, and this year in class, about a special factoring which is done by grouping. What if I have x squared, x to the third minus 2x to the second, minus 9x plus 18, minus 9x plus 18. We're going to go ahead and factor this out. And we said we always want to group the first two and the last two. Keep in mind you can do it the other way too. You can do first and third and second and last. I would always stick with the first two and last two because it's easier. What did the first two have in common? An x to the second power, right? That can come out. I had an x to the third. I took an x to the second. 1x is left. Minus 2. These, I took everything out. There's nothing else left, right? In here, one has an x, one doesn't have an x. I can't pull an x out. But that negative 9 divides both places. I can go minus 9. Well, negative 9 divided by negative 9 gives me a positive 1x, or just an x. Positive 18 divided by negative 9 gives me a negative 2. We factor stuff out, and if you remember from last year, look at this. What do they now have in common? This one and this one, correct? So I can go x minus 2 and cross it out. And write in my next parenthesis, what am I left with? X squared minus 9. Remember this formula? A squared minus b squared equals a plus b, a minus b from chapter 5 and beginning of chapter 6. Don't ever stop here because you want to look at this and see if these both are perfect squares, because if they are, we can go further. This becomes x minus 2. Oh, sorry, 2. And I can say my a is x, my b is 3 because 3 squared is 9. So this can be written as x plus 3, x minus 3. So never stop before you're sure you factors absolutely everything out, okay? The last type of factor we talked about in class is the one that's probably the most difficult, and it's going to be the most confusing for you, but I believe in you. What if we have 81 x to the 4th minus 16? And we go, okay, how can we do this as a good factoring, or how do we look at this? Well, let's think about this for a second. I don't have a cube, so I can't use these two formulas at all. But 81, if I need an A and I need a B every single time, and then I get to decide what I'm using, 81 is definitely the square of 9. X to the 4th is the square of x to the 2nd, right? Because x to the 2nd, all of it to the 2nd becomes x to the 4th, right? So I know that this is the square of 9 squared. 16. Is 16 a perfect square? Yes, it is. 16 is the perfect square of 4. So I have two numbers squared with a minus in between. That's my formula. So this becomes a 9x squared plus 4 times a 9x squared minus b, or minus 4. And at this point, you're going to say, I'm done. And you can't be done because you want to look at these. I'm going to go ahead and erase this now. And see, as soon as you see a minus, you want to make sure this cannot be applied again. Well, let's look at this. Is 9 the square of something? Yes, it is. Of 3. X squared is the square of x. I have my a. 4 is the square of 2. So this is yet again a difference of squares. So this can be rewritten as the first parenthesis gets copied, and then it becomes a 3x plus b plus 2, a 3x minus b minus 2. Now I am done. This is not a cube. That's the only place where I have a sum. And these ones are just first degree x's that cannot be factored anymore. So the key with these is to, first of all, be able to determine what formula you're going to use and make sure you don't stop and we can continue. The last one we did is probably the most confusing one. And that is 4x to the 6th minus 20x to the 4th plus 24x to the 2nd. As soon as you look at this, you realize this is not a cube. I can't use any of this, but 4 divides every one of these numbers, so 4 can be pulled out. Not only a 4 can be pulled out, but I have an x to the 2nd, an x to the 4th, and an x to the 6th, which means an x squared can be pulled out. Let's look at this. 4 divided by 4, 1. I don't need to write it. I had x to the 6th. I pulled an x to the 2nd out. I'm left with an x to the 4th. Why? 6 minus 2, 4. Minus 20 divided by 4, 5. X, 4 minus 2, 2. Plus 24 divided by 4, 6. X, 2 minus 2, 0. Any number to the 0 power is 1. I don't need to write it down. Now I look at this and I go, what if I name x squared a different letter? I'm going to write this as m. That means x to the 4th power is m squared, right? So let me rewrite this as, I'm going to leave this alone. It's going to stay, well, 4m, because that's what we named it. X squared is m, parenthesis, m squared minus 5m plus 6. Okay? I renamed x squared something else, and then I plugged it in. This is just a regular factoring. This becomes 4m, parenthesis, m minus 5, m minus 1. Normally I just put the two parentheses. I'm looking for two numbers. They times, sorry, this is 6. Okay, this is 2 and 3. Don't listen to me. They times the positive 6, that add to negative 5. 2 and 3, right? And now that I'm here, I started with x, I can't end with m. I'm going to go ahead and replace everything. This becomes 4x squared, because that's what m is, parenthesis, x squared minus 2, x squared minus 3. I need to make sure that I can stop now. So I'm going to look at this and I go, is 4 a perfect square? Oh, it's 2 a perfect square? No. It's 3 a perfect square? No. That formula does not apply. I am officially done. Now, the last things we did in this chapter, which I'm expecting to be slightly confusing, is solving for a polynomial. Okay, so let's look at an equation. 2x to the 5th plus 24x equals 14x to the 3rd. We said in order to solve something, we always want equally to 0. I need to move this on the other side. 2x to the 5th minus 14x to the 3rd plus 24x equals 0. Why did I put in the middle? Because we always want to keep a polynomial in standard form from the greatest exponent to the least of the exponents. I'm looking at this and I'm going, I have an x everywhere. I can pull an x out. And I have a 2 and a 14 and a 24. That means I can pull a 2 out. The 2x can come out. What am I left with? 2 divided by 2, 1. I don't have to write it down. X, 5 minus 1, if I need to put it there. 4 minus 7. X to the 2nd, 3 minus 1. 2 plus 24 by 2, 12. And this is an x to the 0 power. I don't need to write it down. Equals 0. I can factor this. And we can do this using that same method we did before. I can say m equals x squared, which means, well, let me do it the other way around. X squared equals m, which means x to the 4th equals m squared, correct? So let's go ahead and replace everything we have. This is just going to stay 2x because I can't do anything about it. 2x, m squared minus 7m plus 12 equals 0. Let's go ahead and factor this out. We know how to factor. This is just a simple binomial. 2x, 2 parentheses, m. I know there's 2 minuses. And I get, I need 2 numbers times to a positive 12, add to a negative 7, minus 3, minus 4, equals 0, right? I can't continue like this. I need to put my x's back in. I end up with 2x, x squared minus 3, x squared minus 4 equals 0. And this is where you start putting them each equal to 0. Either 2x equals 0, which means x equals 0, or x squared minus 3 equals 0, which means x squared equals 3, which means x is plus or minus the square root of 3. This could have been factored more, but believe it or not, I'm not going to because I don't need to. I'm going to go ahead and go x squared minus 4 equals 0, which means x squared equals 4, which means x equals plus or minus 2. Remember, anytime you take the square root of something, you put a plus or minus in the front. So in this case, we had 5 solutions. 0, plus or minus root 3, plus or minus 2, which really makes sense. You know why? My leading exponent was 5. I needed to have 5 x's. That's how I know that. That's how we solved it. The last example in the book is a real-life problem that deals with a volume. I'm going to go ahead and erase all this. Let's look at it. It talks about the volume of a huge hydraulic concrete block. Okay, so what do we know about volume? Again, common formulas. This is a concrete block that makes it a prism. So this is volume is length times width times height. Here's what we know about this problem. The volume is 330 something. I don't remember. The block dimensions are 3x, so my length is 3x minus 11. Is that right? 13x minus 11. My width is 13x minus 13. 13x minus 15. They want to know what is my height. So we're going to have to figure out, solve for 0, and get the absolute solutions out. So let's go and see what we can get here. 330 is 13x minus 11 times 13x minus 15 times my age, right? Is this where we are? Is that what we're going to do? We're going to name this x because apparently that is the height they named it. The blocks are x yard height, so my height is x. And we're solving for x. This is not the nicest problem that you're going to run into, but it's not a big deal. 330 equals, this is FOIL, so this becomes 196. Now 169, sorry, that's 14. 69 x squared minus, I don't know what those numbers are. This is going to drive me bananas. Oh, they did it in the book for me. 338 x squared plus, okay, first outers. Oh, they already did it. Don't listen to this. This is wrong, what I'm doing right here. I'm going to have to use my calculator. So this becomes, the only right number is 169 x squared. 69x squared. That's my first. My outers is, second quit, 13 times 15, 195x minus 11 times 13, 143x, and then plus 11 times 15, 165. And all of it times 2x, okay? When I get all of these together, this becomes 833. So this becomes negative 338 x plus 165 times x. I go ahead and distribute my x. I end up with 169 x to the third minus 338 x to the second plus 165x, and I need to move this to the end, minus 330 equals 0. This is one really, really, really ugly problem, believe it or not. It really is an ugly problem, right? Now, I'm going to look at them and go, is there anything that I can get out of them to somehow get them to look alike? And believe it or not, if you double this, you're going to get that. So this is specifically made that way. I can get 2x squared out of this, end up with x minus 2, because 338 divided by 2 gives me 169. And then on this one, I can plus 165, and end up with x minus 2. And here's why. If I go 330 divided by 165, I get 2. So I can pull a 165 from here, and I can put a 2x squared from here. So this becomes 2x squared plus 165, all times x minus 2 needs to equal 0. I like this solution. Why? This is not going to be possible in real life. You're going to end up with 2x squared equals negative 165, and you stop here. In real life problems, no number raised to the second power will be negative. They have to be positive. So this cannot exist. My only option is x minus 2 equals 0, which makes my x 2. So the height of that block is 2. And if you need to know all of the dimensions, you're going to have my height is 2. My length is 26 minus 11, 15. And my width is 26 minus 15, 11. And those are the, we only needed the height, but that's the dimensions. So whenever we had to factor this out, one quick look at these two numbers would show you I can factor not 2, 169, that's what I meant to say. 169 and 169, I messed up. Okay, I can factor that whole number out because it divides both numbers, and I can factor all that number out. And then I easily looked at this and thought about real life situations. No squared number can be negative. We just talked about this in chapter 5. We had imaginary numbers, but not real numbers. And that is all for 6.4. I know you're going to hate this chapter. I'm sorry. Love you.